Hello everybody. Today we shall look into session 4 of Analytical Chemistry, chapter Structural Elucidation of Organic Compounds. In this session we are going to discuss about H index, how to detect presence of nitrogens, and what happens when there are chromophores and auxochromes in molecule. Let us look at first H index. We have already in our previous session studied about double bond equivalence. Double bond equivalence and H index will give us the same kind of results. Both are used in order to find out how many unsaturations are present within the molecule. H index will give us how many hydrogen atoms are in shortage, which means how many double bonds are present within that particular molecule. We can use this formula. Degree of unsaturation is equal to, which is nothing but the H index, is equal to 2C plus 2 plus N minus H minus X divided by 2, where C is number of carbon atoms, N is number of nitrogen atoms, H is number of hydrogen atoms, and X is number of halogen atoms. Okay, this will tell us the sum of multiple bonds plus rings. In similar way as we have predicted in double bond equivalence, this is helpful. This does not specify exactly how many double bonds or rings are present, but it can give us an imagination of what are the different possibilities of double bonds and what are the possibilities of ring, similar to your double bond equivalence. Okay, so I repeat, H index gives us degrees of unsaturation or index of hydrogen deficiency. In a hydrocarbon with no double bonds or rings, the number of hydrogens and carbons is related as follows. Hydrogens is equal to twice carbons plus 2. Each multiple bond or ring reduces the hydrogen count by 2, which we refer to as degree of unsaturation. The degrees of unsaturation in a molecule can be calculated from its molecular formula using the following calculation. Okay, so degree of unsaturation, that is H index, is equal to 2C plus 2 plus N minus H minus X divided by 2. Let us use this formula and solve few problems. Check here. We have C6H14. Okay, it is hexane. We know this is CnH2n plus 2, which means there should be no unsaturation, right? It is an alkane without any unsaturations. Hence, your hydrogen deficiency is equal to 12 plus 2 minus 14 divided by 2, which is 0. So, there are no double bonds or no rings in that particular molecule. Say you have the formula C6H12. There are two possibilities. See here, this is CnH2n minus 2. This fits into that formula, which means there should be one double bond at least. So you can write it in two ways. It can be hex 1ene or it can be a cyclohexane. When you calculate the hydrogen deficiency for both, you're going to get 1. But for hex 1ene, we have one double bond. Whereas for cyclohexane, due to cyclization, it would have lost 2 hydrogen atoms and hence the deficiency will become 1. Okay, this is how you're going to apply H deficiency formula and arrive at the conclusion whether there is a double bond or a cyclic ring in it. Presence of nitrogens. How do you detect it? So we have the famous nitrogen rule, which has been there in your mass spectrometry, right? So the nitrogen rule states that a molecule that has no or even number of nitrogen atoms has an even nominal mass. Okay, so which means if you have even mass, if the mass is even, then you have either no nitrogen atoms or you may have even number of nitrogen atoms. Whereas if a molecule that has odd number of nitrogen atoms will have an odd nominal mass. Okay, so mass means molecular weight. Nominal mass means molecular weight. If the molecular weight is even, it indicates that you have even number of nitrogen atoms or no nitrogen atoms. If you have odd molecular weight, then you will have odd number of nitrogen atoms. This is the nitrogen rule. So based on the nitrogen rule, we can say when we have molecular weight in our hand, you can to one extent predict whether there is a nitrogen or not. If there is nitrogen, how many nitrogen atoms may be present, whether it is odd number or even number. Next, what is the use of UV visible spectrophotometers or UV visible spectrum which you get? You can predict whether you have an chromophore or an auxochrome. So during a reaction, say you have carried out a reaction and you have introduced a chromophoric group in it. Chromophore is a substance which imparts color to the particular compound, right? You know that. For example, when you do nitration of benzene, you get nitrobenzene. Benzene is colorless, whereas nitrobenzene is light yellow in color. So this light yellow color is imparted because of introduction of a chromophoric group. So benzene will have a particular lambda max. Say this graph belongs to benzene. Okay, it's not, but let us hypothetically consider that. So if benzene gives a lambda max somewhere here, and then after reaction, you have introduced a nitro group, a chromophoric group, what should happen to the lambda max? Okay, so on introduction of a chromophoric group, the wavelength of that particular compound, that is the wavelength of absorption, should increase, right? You are introducing a chromophoric group. When you introduce a chromophoric group, there will be conjugation, more number of conjugation. So when there's more number of conjugation, the wavelength which it is going to absorb will be higher. So this peak is going to shift towards this side. Okay, this side, right side. Hence, that shift is called as bathochromic or red shift. It is going towards IR, infrared. Therefore, it is called red shift. Okay, so this is what happens when you introduce a chromophoric group. If you remove a chromophoric group in a particular reaction, see, the wavelength of absorption should automatically decrease. Say from nitrobenzene, if I am going to remove nitro group, I carry out diazotization and I am going to heat it. So benzene diazoxide chloride will eliminate nitrogen gas to give me benzene once again or phenol. So I am going to remove that particular NO2 group. What happens? That time the wavelength of absorption decreases. So there will be a blue shift occurring. So it will come towards the left. So such a shift is called as hypsochromic shift. Now next we have two more shifts, hyperchromic and hypochromic. These two are in response to auxochromes. Okay. What are auxochromes? They are auxiliary chromones. Auxiliary means they help the chromophores. They intensify the color which has already been given by a chromophore. When you intensify the color, the peak should raise up. It should raise up. Hence, presence of an auxochrome will lead to hyperchromic shift. Hyperchromic shift, that is, raise in the peak occurs. If by any chance there is degradation in a molecule or you are going to remove the auxochrome, that time what happens is there will be a decrease in the peak height. That is, hypochromic shift is going to occur. So You have four kinds: red shift, blue shift, hyperchromic and hypochromic shift. You should know about these before you solve the particular problems. Okay, so here is homework for you. After all this, we have looked into H index, we have looked into nitrogen rule, and then we have looked into what is hyperchromic or hypochromic shift. You're supposed to calculate the H index for the following compounds. Okay, you are going to calculate the H index and write the inference. In inference, you're going to tell how many double bonds or how many rings. Similar to the ones you have done in the double bond equivalence. You're going to put them all here. Okay. Prepare this tabular column and then post it in that particular Edmodo group. Okay. Next, we move on to what are the basic steps involved in the structural elucidation of organic compounds. First, if percentage composition is given, you have to arrive at the empirical formula. Okay. From the molecular weight, either given or from the mass spectral details which you obtain, that is, the molecular ion peak will be directly proportional to the molecular weight of the molecule. Hence, the molecular ion peak will tell us what the molecular weight of the molecule is. From that, you can arrive at the molecular formula. Okay, first you have to find out the empirical formula and then you have to find out the molecular formula. Sometimes you will have only molecular weight given. You will not be given this percentage composition. But they will tell you what are the elements which are present. Say they have carbon, nitrogen and oxygen, like that. They are not going to give you percentage. That time you have to detect the empirical formula using the molecular weight. And then you have to arrive at the molecular formula. Okay, you can do that. We shall see few examples. Then you'll come to know later on how we do that. Then you calculate the double bond equivalence or hydrogen deficiency. Initially, I suggest you do both double bond equivalence and hydrogen deficiency. Afterwards, in your examinations, you can restrict yourself to only double bond equivalence. And from molecular weight, check if there is any presence of or absence of nitrogen. If they have given that these elements are present, then you did not tell nitrogen is present or not. If they do not give anything, then you have to find out. You have to guess whether there is nitrogen or not, depending upon even or odd mass weight. If UV visible spectra is given, check for the presence or absence of auxochromes and chromophores, depending upon the lambda max values. And then look for possible functional groups from the IR data which will be provided to you. Apply your knowledge about NMR spectra and look for number of types of protons in them and arrive at the possible structure. Sometimes you will have mass spectral data also. After you predict the structure, you are going to interpret the fragmentation patterns. Okay. Initially, mass spectra, you can use it only to find out the molecular weight. Initially. Afterwards, you are supposed to interpret it if they would have given you the peaks. Okay. If they have given the peaks, you have to interpret what are the fragmentation patterns which are possible. Then you're going to arrive at the possible structure of the molecule and justify your answer. Which means after you write the answer, you have to draw a tabular column and explain how you have assigned the functional groups and how you have got the NMR spectra. And on what basis you have given, you think that there is a chromophore present or absent in that particular molecule. Okay. So in the tabular column, you're going to put all these data. However, you're going to calculate them, these particular things. The first 4 points are going to be calculated separately. Okay, I hope you have understood this now. Thank you. Kindly complete this table and submit your assignment.